Hey, how's it going? Welcome back for day 17 on Advent of Code here. That's quite a lot of code today, so I'm not going to step through it line by line. I'm just going to do a quick overview of what I did and my thought process. I only got part one correct. I did get to part two. I took a good stab at it and was able to get the right answer for the sample data, but not for my data. So, anyways, I'm punting part two for now. May come back to it later. Otherwise, I'll catch you for day 18. So, let's have a look. I took an object oriented style to this using the class keyword in JavaScript. I thought that made a lot of sense with how the rocks and the board are, and kind of basically simulating Tetris was how I built it. So if I bring up the terminal here and just run our code, this is the empty board that it prints. And each time I click spacebar, it's going to show us where the rock spawns and then where it ends up after the jet is applied, and then it drops. So if I just keep pressing spacebar a couple times, we kind of see what happens with my input data. So we got this block coming all the way down there and all the way down there. Anyways, you get the idea. So I'm going to show you how I built that, and then I'll show you the game loop that we can use to go ahead and make that actually work. All right, the way the code works up here, I'm just, these are for spacebar. How I implemented essentially waiting for the keystroke. I just use these lines of code, and then this is going to be used later to read in our input data. The array of rocks that will map to grid positions I define here. So this is just an array of arrays, and so this is the horizontal line, has x position of 0, the row of 0, and the column, okay, I'm saying this right, 0, 1, 2, 3. And these are all the different shapes. And then I have the spawn height is 3, so the problem says that we spawn a rock 3 from the top of the tower, or the last piece of the tower, I should say, and then the spawn column, which is 2. And so let's get into our class rock that I defined here. A rock has a row, a column, a width, a height, and positions. I think these are all pretty self-explanatory. Positions is a two-dimensional array of numbers, and this just populates with the positions that the rock takes up on the board. So we set row and column equal to start row and column, and I initialize max height and max width to 0, but as we map the positions to their proper location, we'll update that as well. So all this positions.map function is doing here is taking the initial 0 indexed spaces of the shape and mapping them based on the start row and the start column. And then we also just take the max height and max width to get the size of our piece. And then we set those down here. And then we define some functions that a rock can do. So we want a rock to be able to check if it's bottomed, which all that does is return if 0. We want to check if it's colliding with another locked piece on the board. So I have this concept of locked pieces that comes up on board. Maybe I'll skip down to the board. This is the other big class we have is board. A board has a grid, which is a two-dimensional array of strings. And this just represents how the pieces are on the board. We have the active rock, which is the rock that's moving. We have locked pieces. That's what I was referring to earlier, two-dimensional array of number. Once a piece stops falling, locked pieces is what tracks those rocks. And then we have our rock number. The question does ask for how many, what is it? It wants to know, like, after 2022 rocks have dropped, how tall is the tower? So we have to keep track of rock number. And then I have my constructor here to initialize the grid as empty, basically filling it with these period characters. And then I initialize locked pieces to an empty array, the active rock to null, and rock number to 0. The last bit to know is my code right here. So we create a new board. We set our jet index to 0. We read in the input data into this variable called jets. We print the empty board, and then we wait for key press. If the user presses space, then this is our game loop right here. Is these 3 lines of code is going to call all the other code above. So we let the jet character equal jets of jet index. We update the board based on the jet character, and we update the jet index after the board has updated. So if you reach the end of the jet string, then we want to set jet character back to, or the jet index back to 0. Otherwise, we just increment it. So let's have a look at the update function within board. That's this one. Does most of the heavy lifting. First, we want to place a piece if there is no active rock. Then we want to apply the jet. Then we want to check for bottoming conditions. Then we want to check if our logic is actually finished. Finished. And then we print the board just for fun. So big things to know here. If there's no active rock, then we call this spawn rock function. We'll look at that in a minute. Then we apply the jet. Then we check bottom collision. I was kind of getting into that. We're passing the locked pieces over to that. And we move down if none of the bottoming conditions are met. And then we check finished. So let's go back up to rock. Rock right here, you can see it has, let's see, check bottom to check bottom collisions. This just takes locked pieces, and it's going to go ahead and loop through everything. And if locked piece, if the row and column of our current active rock coincides with a locked piece, something that's stored in our locked piece array, then we know to return true that there's been a bottom collision, and we can lock that piece. Rock also has a move down function and a can. It should have a can. Oh no, move down just really moves the rock down. This is kind of going to get called all the time. And then we have a can move right and a can move left right here, and a move right and a move left. So can move right, it checks that the rock is going to be in bounds. If it's not, then return false. Then we check for locked pieces, preventing the rock from moving right, in which case you return false. Otherwise, we've passed all our tests and return true. And all move right does is it checks if it can move right. If it can't, then it just returns. Otherwise, it's going to map the positions over one to the right one, and we increment our column. This column, again, refers back to the parameter that a rock has, so it knows about its own row and column. And can move left and move left are pretty much identical to can move right, just changing the boundary conditions, in this case to 0, and mapping over to -1, also checking that the locked piece at the -1 position doesn't exist. And then lastly, we have apply jet, and that's to the rock. And so if the jet is this little right character, then we call this dot move right. And if it's the left character, then we call this dot move left. So that's everything to do with the rock. I don't think there's anything else I want to touch on with that. So next is the board. We have this spawn rock function. This is going to increment the rock number counter. It's going to get the highest row. I have this helper function called get highest locked piece row, so that we know to spawn 3 above that. And where is that? That's down here. So all this does is it loops through every piece in locked piece and returns the maximum one of that. And then we can create a new rock, and we're passing it here the row to spawn it at and the column. And here we're getting from that rocks array up at the very top of this this file. So we're going to get rock number -1 and mod rocks.length. So that's just going to cycle through this array of arrays that we have here and add this rock to our board. So back down to spawn rock. We want to add grid rows equal to the rock height if needed. So that's all this is doing, is that when we add the rock, before we add it, we need to add some rows to the board. We do that here. And then we just set our active rock, this dot active rock equals new rock. We talked about, so lock piece is when the rock knows it's, if I come into the update function here, so we did spawn rock, we looked at apply jet, we looked at checked bottom and check bottom collisions, and now when these are true, we want to lock the piece. So that's the function that we were just at here. We push the active rock positions to our locked pieces positions and set this dot active rock equal to null. Otherwise, we call move down from the rock method. And we have this check finished. If we check finished, and all that does is say if we're, we could specify this based on the problem, but we want to know what happens after 2022 rocks have fallen, so return true. So once that happens, we'll get the highest locked piece row +1. That's going to be the height of all the pieces that have fallen. And we'll throw an error so that we break from our game loop. And that should be it for part 1. So I wanted to show you with the key press how we can I used that for debugging to make sure that everything was working. But if I comment this out and uncomment this and save, bring up my console. Oh, I should have turned off the prints. Okay, so I turned off the print statements in the update loop. Let's run it. 3098 is the answer for my response. And now for part 2, the way I tried to tackle this, let me go ahead and comment this out too, was basically to find a cycle in the rocks, that after so many rocks have fallen, there will be these cycles that occur. And so cycles map is essentially a cache, and I have this cycle finder function. And this loop here. So what I want to do, this while loop is the exact same as above these statements here, but then I check if the active rock has gone to null, which means we're placing a new rock. I want to look and see if that last one created a cycle. So I have cycle finder at board. I just call cycle finder on the whole board. This gets the top 4 rows from the locked pieces array and creates a cycle key. And I take the pause of 1, which is the Y position, because I don't really care about the X position. Sorry, the row. The row is what's going to cycle, but the column of locked pieces is going to tell us what is the cycle. So if the length is less than 28, this is just for the first time as we're building up to 28 pieces or 28 4 rows. If we don't have 4 rows, essentially we won't have a cycle key. So that's why we return this here. It's just going to keep redoing our cycle finder. Otherwise, if we get cyclesmap.cycleKey, then we know we found a cycle, and that's what's in our cache. Otherwise, down here, we get the height, the num rocks, and we add to our map or our cache. Otherwise, we add to the map the cycle key with a value of height and num rock, because we'll need these once we know we found a cycle. And we'll just return here and wait until we do find a cycle. So in this block of code is where we've actually found the cycle. And it's just a lot of computation here. So I get the height and the rocks, and then I calculate the height of one cycle. I calculate the number of rocks per cycle. Then you need to calculate, so you have the number of cycles. You have this number, which is how many rocks we want to fall in total, but we also still have rocks to fall. So the way I do it is I simulate the ground level plus up to the cycle, and then you would just add the number of cycles times the height of one cycle. So that's what's going on here. And then you would also need to simulate the rest of the rocks falling to get to this number here. It's a terrible explanation, but I'll just go ahead and run the code and show you. So we have all these cycle keys. Oh, this is on my input, which isn't the right answer. So let me change this. So I'll change the jets to the example input, and we'll go ahead and run again. And so we can see some interesting stuff here. Here's the cycle key when the cycle starts. We can see we're adding all these cycle keys, and then we find one that matches. So that's our cycle. And the height when the cycle start is 39. The number of rocks when cycle started was 22 rocks had fallen. The height of one cycle is 53. The num rocks per cycle is 35. This is the amount of rocks that still need to fall, which we would subtract from whatever 1 trillion, I think it is, and remainder of the rocks. And so I get this answer, which is right for the input example, but when I run this on mine, it doesn't work. So maybe it helps, maybe it doesn't, but that is it. Thank you for watching. This has been day 17. I will see you for day 18. Goodbye.